Done. It's done. Uh, in LMRF, okay, we were discussing Schmidt trigger, and then of course after Schmidt trigger, we were discussing the square wave generation. So let us move on to one more circuit. So we just observe this circuit. Uh, so let me just write. Okay, this is minus plus. Suppose if I have some signal, some V in, which is a square wave. Assume that V in is a square wave. What is V out? So what is this circuit? So if I say this is R and C, let me also write a circuit, this one. What is this RC? If you have same square wave here, same square wave, so what is V naught? So this is without ampere, here this is with ampere. What is this circuit? Can anybody say? Integrated circuit. So what is the expected output? Suppose if you assume that this is the time for this, okay, on and off time. Suppose I say this is T1 and T2. If the RC time constant is too much greater than T, okay, where assume that it is either T1 or T2. Suppose if T1 is equal to T2, if the RC time constant is very, very greater than T1 or T2, for this circuit, does it keep taking some time, and then by the time this reaches the capacitor is only charged to this much? So since the input voltage is reduced, so will it go like this? Suppose if I have the input voltage going like this, so will you get a charging discharging, because the RC time constant is so high that so within this time capacitor cannot charge to greater voltage. Am I correct? So suppose if you reduce the time constant, then it will charge quickly. You can see it will charge quickly and then it will go here. So it will just charge quickly and then it will go here. See here? So this is if RC time constant is almost equal to T or less than T. So the condition what we are assuming is that let RC be far far greater than the available time. This is the waveform which is going like straight here. It's actually, suppose if you take capacitors always charge exponentially. Am I correct? Suppose for this circuit, if you apply DC voltage, if you apply DC voltage, will it actually charge like this? Will it actually go like this exponential charge? In this exponential, suppose you consider only this part, will it look like almost linear? This is actually 1 e power minus t by RC. Correct? This is actually expression for a very small t time period. Will it look like almost like a straight line? That's what I've written here. You can see here, this would have actually taken a path which is exponentially like this. Since it is not going, you are not allowing the input to be like this for a long time. It will go like this and it will again come down. Correct? So if you apply a square wave for this integrator, keeping RC far far greater than T, you will end up with a waveform which is charging and discharging almost. Voice is breaking. What to do? Please manage. Yeah. Is it breaking for all of you? Sometimes. Okay. So let us get it. Of course, even though it is slightly breaking, I think I could able to convey what I want to convey. So this is what is happening here. for this circuit. For this circuit, so suppose if you take the same input here, same input like okay square wave, if you consider a positive square wave, see here, this is still an integrator since it is connected to inverting terminal, will it actually happen the opposite? So instead of increasing like this, so if you assume that initially it was some positive value, this will actually come down. This will actually come down. For negative volt, just a minute. Let me just connect it through my mobile only for the voice. Okay, how do I do this? Is the way how I do it. What is that? Today's okay, today's 10th. I joined. Let me change the recording settings here. Otherwise, it is going to echo there. Desktop audio. Yes, reduce this. I will reduce this desktop audio also. Let me take only the mic inputs. Okay, fine. Done. Uh, One second. Is this fine now? I hope my voice is clear.
Yes, but it's somewhat low, sir.
How about now?
Um,
So okay, now I just okay speak very close to my. Okay, what I want to say is here when it was only RC circuit, so the input voltage was increasing. For the input voltage constant, output voltage was increasing. When the input comes down, so this is coming down. Correct? Because of inverting action of this op amp, whenever the input voltage is positive, the output is keep reducing. And when the input is constant in the negative, it will happen the opposite. So now, if it is a square wave, will it look like a triangular waveform? You're trying to generate a triangular waveform because you might have seen that all generators doesn't have an input source. Am I correct? So here actually have an input. If I won't give an input, I will not get the square wave. So what we'll do is instead of giving an input in the form of a square wave, let me take this output of the integrator to a one more circuit. What is this circuit you are looking at? Uh, See here, this is R1, R2. Is it an integrator followed by a integrator? Sorry, is it a Smith trigger followed by an integrator? So assume that initially, if I say this is my V1, this is what is, assume that V1 is plus Vset, correct? The V1 is at plus Vset. What is V0? Because as we saw here, when the input, when with this Vin was high, was it going down? So does the output V0, will it be keep going down? So this will be keep going down. See now, do you have a Smith trigger here? So what is the voltage at V plus here? V plus is equal to V1 R2 by R1 plus R2. Am I correct? So you're there at plus Vset and the voltage at the inverting terminal is keep going down. So are we looking at one minus beta Vsat and other one plus beta Vsat, where beta is equal to R2 by R1 plus R2? So now, as long, okay, this input voltage is above minus beta Vsat. In such case, is this is more than V minus? Does it mean that output will remain in plus Vsat? As long as this is a plus Vsat, is this keep on going down? When it tries to go below minus Vsat, what will happen to this? It will come to minus Vsat. Correct? Now this is at minus Vsat. So as soon as this becomes minus VCC, does the voltage here starts charging towards positive? Can see now it is going up now. Again, when it tries to cross plus beta Vsat, output makes a transition. That is, V1 makes a transition from minus to plus. So does this continues? So now, if you look at this V0, is it not a triangle? So now this is triangular waveform generator. It's a combination of course, it can certainly give it to it, it will be reverse. Hmm. It's not non-inverting. You have to give it here. You have to give it R2, not here, because inverting split trigger you are giving the input to this resistor. Am I correct? So you can get of course it will be still a triangular waveform, but the initial phase will be different. Is that clear? Now we started from giving a square wave to this integrator. We found that it will result in a triangular waveform. Now, instead of giving an input voltage externally, I want to generate that square wave, whatever plus VC is minus VC is required, you are getting it from a Schmitt trigger. So, there is a triangular waveform generator. How do I change the frequency of this triangular waveform? Can I change the frequency? Okay, can frequency be increased by reducing either C value or R value? Okay, so meaning that it will charge quickly or it will discharge quickly. So it will happen fast. Correct? What is the impact of R1, R2 on the frequency? What is the impact? So because for any waveform we have two things. We have amplitude of the signal and we have the frequency. If I change the value of RC, is it possible to change the amplitude of the frequency, amplitude of the triangular waveform? Or amplitude is controlled by whom? Beta Vsat. So beta Vsat, because if you can see here, this is your amplitude. So R1, R2, and the Vsat value will decide what is the height as well as the frequency. If you change R1, R2 along with the height of your waveform, does the frequency also increase or change? So R1, R2 will affect both amplitude as well as the frequency of the triangular waveform. Will it make sense? How about RC value? It will only change the frequency. So amplitude remains the constant because it has to go up to beta Vset and minus beta Vset. Okay. So this is about triangular waveform generation. Any issues to anybody? Let me see how many of you are there. Oh, great number, 40, 44. 21 ಜನ ಇಲ್ಲ ಹೋದ್ರಪ್ಪ. They are sleeping. Okay. Uday Shankar. Uday? Hello, Uday. Uday Shankar, you. So we thought, okay, 41, 44 students are there. How about Venkat Sai? Sai Venkat Sandeep. Okay, fine. Uh, Suppose if I want to generate a waveform, something like this. This is the height. Can you see what is happening here? Now this is 0. Let me write, okay, this is one category. In the second category, I want to have something like this. This is 0 volt. Okay, this is 4 minus 4. This is 4 minus 2. This is the reference. Assume that slope is x and y here. This is x and y. So here the slopes are x, x. How do I generate this waveform? How do I generate this type of waveform? Of course, it's open to all. My question is, how do I generate a waveform having different steeps? Of course, here the slope is bit okay. It's not so steep. Here it is coming down quickly, and here you can see the slope of rising and coming down are same, but the amplitudes are different. But here the amplitudes are same. In which case, what are the change in circuit you want to make? Shall I do something like this? Will it work out? So this can be for the first circuit. Will it work out? They are no. They are in different direction. No? This. No, anyhow, it is because this is your source. It happened the same because it is again the charging discharging through R. RC time constant. Whether you change R or C doesn't matter. Correct? Different slope. How about this? The amplitude of my okay negative voltage, negative okay part of your triangular waveform is less compared to the positive part. Anybody? See the variations. We started from a simple RC network. We had this. Now we are looking for different varieties. Because maybe in AD kit, you might have seen that 50% duty cycle or 20%, 90%, something like that. Suppose you want to have 90% duty cycle in this triangular waveform, it comes like this. See here? Suppose you want to generate something like this, it has to discharge very fast and it has to charge very slowly. Fine. This is also a type of triangular waveform, which we call it as sawtooth. Because in that sawtooth, okay, will you have something like this? Correct? There is no sub. Okay, this is slope. Okay, how do I get different amplitudes here? I have X. Yeah, perfect. So you just give some V reference. If you give a V reference voltage, then VTH VT will change. So if that changes, that will make your requirement. Is that correct? So V reference along with this different slope and different amplitude. If you only want a different amplitude, only V reference is sufficient and let's have a single R. Different slope, no reference, charging distance was different. If you want to have both, have this as well as this. Correct? Okay. We'll just okay. I'll give you the answer for this maybe later in the day. Uh, I think I have already shared videos of what is that? Precision rectifier. So any issues in that? So any clarification required? Shall I just explain quickly? So even though it is there in the video, if you want to listen to me again, uh, what is the definition of a precision? Of course, you already seen work with rectifiers. What is a typical rectifier? Hello. AC to DC. What are the requirement? It uses what predominantly? It uses diodes. So what is the requirement of a typical diode? No, typical. Ideally, of course, anything more than zero, it will turn on. That's what. Okay. The input voltage. Okay. No, it's not VTH. Threshold. No, threshold or cut-in voltage. So input voltage has to be always more than zero point 0.6 or zero point 0.7. Suppose because we are handling the amplitude in terms of tens of millivolts or hundreds of millivolts, if you want to rectify such type of signal, then you can't use that ordinary rectifiers because they require more than 600 or 700 millivolts. If the input voltage is hardly tens or less than 100 millivolt or less than 600 millivolt, then your ordinary rectifier won't work. So we'll go for precision rectifier. Precision rectifiers are used to amplify input signals less than the cut-in voltage. So that is the purpose and the okay. This is how it goes. You have okay. Let me just write this as plus minus. Okay, you will have the input voltage that is applied here. Okay, let me just have it as this as the direction of the diode. Please don't try to mug up the things. Okay, this is what you have. So what is actually output of an op amp? Suppose if I say this is V1, V1 is equal to is it V plus minus of V minus into A? Am I correct? A is nothing but the open loop gain. Correct? This is the same diode. This is the ordinary diode which has got around 0.6 or zero point 0.7 volts. So now this is your load. Here I'm just measuring the V naught. So what is the voltage that is available at V minus? Is V minus is equal to 0 volt. Here, see here, this is grounded. Assume that initially output voltage is 0, diode is off. So there is no current. So the voltage drop across resistor is 0. So this is 0 volt. Now for this input voltage V in, which is applied at V plus, assume that this is in terms of few tens of millivolts. So in such case, is V plus is more than V minus because V minus is 0. V plus is in terms of tens of millivolts. What is V1 then? Assume that A is equal to 10 power 3 or 10 power 5. My video is stuck. Just give me a minute. Let me just stop it. What is this? This is camera. Is it visible now? Wait. Let me share it. Wait. Let me share it. Okay. So as soon as the input voltage goes positive, so what will be your V1? 10 millivolt into so and so 10 power 3. No, will it be because V1 is nothing but V plus minus of V minus into 10 power 3. So this is 10 millivolt minus of 0 into 10 power 3. So this 3 and 3 will go off. Will it become 10 volt? Will you Shaka? Okay, fine. Oh, okay. No. Again, it's stuck here. I don't know what is happening here. Okay, is it fine? Is it to come or is it come? Okay, now it's come. Okay. So is that okay? The moment input voltage is at 10 millivolt, since the gain is 10 per 3, will it become 10 volt at this point? So once it is okay, more than zero point 0.7, will this conduct? So once it conducts, can you see this is becoming a closed path? Then what is this circuit then? What is circuit? What is this? What is this? Voltage follower. So meaning for input voltages above zero, will it act like a voltage follower? Let me just take a disconnect and again connect it back. Give me 1 minute. Over now. Hello. Is it better now? How about now? How about now? Okay, fine. Now, shall we say for input voltages anything above zero, does this diode turns on? So once it turns on, does this circuit looks like something like this? It looks like voltage follower, meaning if I write the transfer characteristics, if this is V in, this is V naught, and if I write this as my reference one, for any voltages greater than zero, if input increases, does output also increase by the same amount? Is the slope one? For any voltage which is less than zero, what will be this? So as we had it here, this is zero. I'm just talking about the negative part. This will be minus 10. So will it be minus 10? This minus 10, will it make this? This is minus 10 into minus 0. That is diode is off. So will it like, okay, so open circuit? When this is open circuit, then what is the output voltage here that you are measuring? Zero. So output voltage is zero. So for any negative input voltages, output voltage is zero. For any positive voltages, output follows the input with the same slope. Correct? This is a half wave rectifier, half wave precision rectifier. If I reverse the diode, I'll get the reverse characteristics. Meaning, if I do this plus minus, if this is V in, if it is R, this slope is 1. This is V naught, V. Correct? So we should just go to one more half wave rectifier stuff. Let me just write this circuit. Minus plus, let me ground this. Again, in case of precision rectifiers, we'll always consider input voltage to be less than V gamma, the cutting voltage. Okay, assume that input voltage is slightly greater than zero. Uh, since it is greater than zero, what might can happen? What will be the voltage here? If the input voltage is slightly greater than zero, uh, will it be like okay minus V set? So will it be like minus V set? Because now we can see when it is minus V set, is this off? If this is off, then what is the output voltage? Yeah, when it is open circuit, so shall I write this as my circuit diagram? Let me write the equivalent circuit. Am I? ಕೇಳ್ತಲ್ಲ ನನಗೆ ನಾನು I'm just okay. I'm listening to my own voice. ಕೇಳ್ತಿಲ್ಲ ಈಗ Hello. Now see here, when V in is positive, does this negative voltage? Does this negative forward bias this? Because I have a virtual ground here, so this will go into forward bias D2. Correct? Because of this negative, is it reverse biased? This diode D1, this is R2. So is V naught is equal to I into R2. So what is I here? 0. So then what is V naught? So why I'm just saying this is I into R2 is your V naught is this is ground means virtually this is also grounded. So during this is V in and V naught, when the input voltage is positive, is the output voltage 0? You take the opposite. That is, if this is your input voltage, this is with respect time, to time, then output voltage is 0. Whenever input tries to go below 0, what will happen to this? Okay, shall I write the same circuit now? So let me write this as R1. This is R1 minus plus. I'm going to have positive voltage. I have a diode. I had one more diode here. I had a resistor R2. This resistor is connected here. This is V0. This is your V in, which you are looking at negative. This is grounded. So since it is positive, this is on, and since this is positive, this is reverse biased. Correct? This is D1, D2. What is this circuit now looking like? Is is it looking like this is R1, R2? This is an inverting amplifier. So during the negative half cycle, is the output voltage is what? So will it be like this? Can it be like this also? Can it be like this also? Depending on the ratio of R2 and R1, shall I write now V naught is equal to minus R2 by R1 into V in? So how does the transfer characteristics look like? Will it look like this, this, this? It can be any slope. Here this is less than 1, equal to 1, more than 1. Correct? If I say this is slope A, this is B, this is C. B is equal to 1, A is equal to greater than 1, C is less than 1. Can somebody say how A is greater than 1 slope? No, no, no. Why I'm saying that okay, that slope is greater than 1? I'm not asking you how do you make it. Why the slope is greater than 1 for A line, A straight line? Why the slope of B is equal to 1? What does it mean? I got it. So what does slope is equal to 1 means? Amplitude of your output is same as the input, of course, in the 180-degree phase. Uh, suppose if I take this ABC, which one shall I name it as ABC? Is this B? Top one? Top one is what? This is A, this is C. Correct? For lesser input voltage, you have more output. So that's why slope is more than 1. Done? So this is also a half wave precision rectifier, correct? You can still make it whatever shape you want. You can just get it in whichever quadrant. We just go to full wave rectifier. The concept here is you have an input voltage V in, you have a diode. Let me call it a super diode. Super diode is one which can able to turn on even at very less voltages, that is less than 13 voltage. So you have this here. You have one more super diode which is in the opposite direction, but the input to it is given with an inversion. This is -1 gain. Suppose if I just put this R, this is super diode 1, this is super diode 2. So will you get this is V in V naught? Can you see this is the transfer characteristics? That is, when the input voltage is positive, output is also positive. When the input is negative, output is again positive. Meaning, if you have something like this type of waveform, you'll get, correct? Of course, now it is, of course, the input amplitude is less than V gamma. That is the major thing. So, how do we realize this? So, this is the conceptual circuit where you have a super diode 1, super diode 2, and you have an inverting thing. Can I just implement this is plus here minus? This is V in. It work out. Okay, shall we write the equivalent circuit during when input voltage is positive half cycle, negative half cycle? So when V in is greater than 0, so since it is greater than 0, will this be on? Because you can see this is because this is connected to this. Here it is 0. This is greater than 0. This is at plus V stat. Then this is on, but this will be off. So will I write it this way? Plus minus. This diode is on, and this is V in. Let me take the same V in minus plus grounded here. This resistor R1, R2. This is open now. This is RA. So what is the waveform that you'll be getting here during positive half cycle? So do we get this part? So whenever V in is less than 0, so shall I make this open? Shall I make this closed? What is the output waveform? So this will be, since it is open, this is off. This is not like, okay, even though it's connected, it's not effective. So you have an inverting amplifier with a gain minus R2 by R1. So does this is having a gain of minus R2 by R1, correct? So now using this, does this slope is always 1? So this is voltage follower, this is having a gain depending on R naught. I can get an input, sorry, a slope something like this. This is V naught, this is slope of 1, this is slope of zero point 0.5, this is slope of 1, this can be slope of 2, this is V naught, this is V. Correct? It's possible. So these slopes you can get it using different resistors. Done? Okay. Okay, this is about precision rectifiers. Okay, half wave and full wave precision rectifiers. How about PLL? Okay, after your for that Smith trigger experiment, what you are doing, I think three groups have finished. G1, G2, G3. Am I correct? The conduction of the experiment. So rest of the groups will be doing it okay today and tomorrow. So afterwards, we will go to this PLL. How much you could able to understand from that PLL videos? What is the role of that loop filter there? Or can you basically tell, okay, what are the blocks that are there for a PLL? Can I get, okay, what is today's date? Today is 10 now. Who is USN 10? 19, ET 10. Hello. Oh, change of name. Then who is 20? 20, 20, 20. Oh, yeah. You have to speak what I say. Yes, sir, the message after that. Hello, who is month? Who is 05? Yeah, fine. Okay, what are the three important blocks in PLL? Hmm? Loop filter. So what is the role of VCO? No, no, no. Okay. Tell me. Hmm. Mm-hmm. Can you able to relate this to whatever that you did in your triple five timer adjustable multimeter? How you relate? No, there also we had a VCO. No? What was the error voltage there? Now, how do you relate the error voltage in PLL to the stable VCO that what you already conducted? Suppose if I say error voltage is zero in triple five timer, what is the control voltage then? No, no. See, you might have observed that if you don't externally give any voltage to that control voltage, what is the voltage? Is it always two-third VCC? If you increase the voltage beyond two-third, does the frequency reduce? If you make it below two-third, does the frequency increase? Is the frequency depending on the signal that is applied at control voltage? If that control voltage is not given manually, if it is taken from a loop filter and then given to it automatically, does the frequency will keep changing depending on your error voltage? That's what is actually happening in your PLL. In PLL, we have a VCO, may not be made out using 555 timer because VCO can be realized by so many data circuits. In that PLL, we don't have 555 timer as a VCO. So we have a different circuitry there. But typically, if you apply a different DC voltage, then it will be running with a different frequency. I think we talked about some free running frequency. Could people able to realize that okay, free running frequency in PLL? What is that? That is when the error voltage is zero. When there is no error, it is running with some frequency. When error comes, the frequency either increase or decrease, depending on the polarity of the error. If the polarity is positive, the frequency may reduce. Of course, vice versa. So this is how your error voltage is changing the frequency of a VCO. So in the next class, we will try to relate how does this frequency of your VCO is compared with your incoming signal, and what is happening in your phase detector, what is the output of phase detector, how does your loop filter will going to control that entire stuff of your PLL. So the next experiment that is there on remote lab will be on PLL. You will see all this lock range, capture range, training frequency, all those things. Impact of that loop filter, so all those things we're going to see it. Okay, then we just stop today's class. So we'll first try to learn the theory of PLL. Then I'll demonstrate using remote lab how do we work with this PLL circuit.